Hello everyone, I will be explaining about the construction of synchronous generator. First, before going into the constructions, we should understand what synchronous generator really means. A synchronous generator is a machine which converts mechanical power to electrical power, which is same as the devices. The synchronous generator is also termed as alternator because they converts or they produces AC power. And synchronous generator, it is called synchronous generator because they are driven at synchronous speed to produce AC power of desired frequency. So before going into the main construction, first we should know the construction difference between DC generator and alternator. So in DC generator, the field is stationary whereas the armature is rotating, and in alternator, it's just opposite of DC generator. Field is rotating and armature is stationary. So some of the advantages of rotating field and stationary armature, that is the construction of alternator. So some of the advantages are: it is easier to insulate stationary winding for high voltages. The stationary three-phase armature can be directly connected to load without passing through slip rings and brushes. Only two slip rings are required for DC supply to field winding on the rotor. And in other advantages are improved ventilation, there's a reduced rotor weight and inertia, ease of construction. These are all very simple to understand. So now to go with the main construction of alternator. So alternator's construction basically consists of two parts. They are stator and another one we have rotor. So under stator we have first stator frame. So this stator frame basically means it provides support or give mechanical support, or it covers stator core, and they are made by bending and welding mild steel plates. And to go to stator cores are made by laminated silicon steel. They are made by laminated silicon steel because to reduce eddy current losses, and they use silicon steel because to reduce hysteresis loss. In the past they use iron core where there is high eddy current loss and hysteresis loss, but the modern machines use laminated silicons, so thereby reducing eddy current losses and hysteresis loss. And to do armature winding, there is a slot on the in the stator core. So here's the diagram of or picture of stator core in stator frame. This is the uh, this is the main, or we can say the real life picture of stator frame. And here we can see this the stator core, and this space between here we can see where the armature winding is done. These are the these are the slots. Now to talk about the armature winding. Armature winding is done on the slots of stator core. So these armature windings are insulated copper windings which is placed in the slot of stator core. I've just said. So this winding is connected in star or delta, and these end windings are connected to the terminal box from where the current is supplied and magnetic field is created. Here this is the end of the windings. Here they are connected to the supply, and here the dot we can see here, this represents the winding that is turned on the stator. This is the stator core, and inside there is this the rotor, and I'll be explaining about that. Now to go with the second part, that is rotor. This rotor carries field windings which is supplied with DC through two slip rings by separated DC sources. So I've just explained it in the advantages earlier. So there in alternator they use two slip rings, and this is in the rotor which carries field windings which is supplied with DC current through two slip rings by separate DC sources. And this DC source is a small DC generator mounted on the same shaft of alternator. And under rotor there's two types of construction. There is salient pole rotor and cylindrical rotor type. And the first type is salient pole rotor. The salient pole rotor means we can say there is a pole here. From the word itself we can understand they use a magnetic pole that is projected out of rotor. So on the outer surface of the rotor they use magnetic poles, and the salient poles are mainly used for the slow speed machines which are driven by the hydraulic turbines. So because they are driven by the hydraulic turbines, they are called as hydrogenerators, and the air gap is non-uniform. They cannot withstand high mechanical stress at higher speeds because they only work with slow speed machines, so they cannot withstand mechanical stress. And the large diameter and small axial length. So here, this is the diagram of salient pole rotor. As I have told earlier, we can see there is a magnetic pole. This is the rotor, main rotor, and there is a magnetic pole that is projected out of the rotor. Next we have cylindrical rotor. Next type is cylindrical rotor. Cylindrical rotor is the what to say now non-projected surface type, and diameter is small and large axial length, and they are used for high speed applications, and the air gap is uniform unlike salient pole rotors. And high speed alternators that is ranges from 1500 to 3000 rpm, they are driven by steam turbines, hence they are called as turbo alternators. So here we can see that this is the rotor, and the outer surface it's in cylindrical shape, so thereby we call it cylindrical rotors. The air gap is uniform here, and this is the overall construction details. Here we can see that there is a stator frame here. We have stator core. These are the slots of stator core where the armature winding is done. We have here brushes, exciters, and this is the rotor. This is the rotor. This part is rotor. Here we have and this construction is of the salient pole rotor because we can see that the magnetic poles are projected outward. So that's all from me. Thank you.